In the previous video, I showed a way of writing an expression in cosine and sine as an equivalent form involving r sine x plus alpha. I'm going to work through a similar example here where we're going to be writing 4 cos x plus 3 sine x as r cos x minus alpha, and then we want to be able to solve 4 cos x plus 3 sine x equals 2 using our answer. So I'm going to move through at a faster pace with this one. Now r cos x minus alpha using the trig formulas can be expressed as r cos x cos alpha plus r sine x sine alpha. That's from the formula booklet. Okay, so expanding it. Now if I reorder that, then that could be written as r cos alpha cos x, writing the cos alpha on the left, and writing the sine alpha on the left. We're going to have r sine alpha sine x. Now if we compare this with the original expression, what is in front of the cos x here must be what is in front of the cos x there. So r cos alpha must be 4. And whatever's in front of the sine x here must be what's in front of the sine x there. So r sine alpha equals 3. So if I call that equation 1 and that equation 2, then I can eliminate the r's and allowing us to find alpha by doing equation 2 divided by equation 1. R will be divided by r, which is 1. Sine alpha divided by cos alpha is tan alpha. And 3 divided by 4 is 3/4. So alpha, making sure my calculator is in radians, because in this next bit I'll be working in radians. So inverse tan of 3/4 is 0.644. Well, 0.6435. Okay, and so on. Now, to find r, if I rearrange this equation to get cos alpha is 4 over r, and this equation to get sine alpha is 3 over r, then remembering that sine is opposite over hypotenuse and cosine is adjacent over hypotenuse, then I can write these in a right angled triangle where the angle's alpha, the opposite is 3, the adjacent is 4, the hypotenuse is r. So r is the square root of 3 squared plus 4 squared, so square root of 25 is 5. So that means I can write 4 cos x plus 3 sine x as 5 cos x minus 0.6435, and so on. So I can rewrite the left-hand side of this equation as 5 cos x, get my bracket right, x minus 0.6435, and I'm wanting that to be equal to 2. That is why we do this first part, in order to allow us to solve the second part. So first of all, divide both sides by 5. So 2 divided by 5 is 0.4. Then you can inverse cosine both sides. So x minus 0.6435 is equal to inverse cos of 0.4, which is 1.15927. Now cosine between 0 and pi looks like this. So 0.4 should just give us one solution there. So that is the one solution that I'm looking for. Now if I add 0.6435 to both sides, it'll give me my only solution. Make sure that's right. So that's 1.80278059, which to 3 significant figures is 1.80. And that is my only solution for this original problem. Okay? And that is how we can use the equivalent form to solve a trig equation like this.